from energy conservation, I can write kinetic energy plus potential energy at point A. Okay, potential energy, I am assuming it is the reference point. So potential energy is 0 here. So I can write that 1 by 2 m VA square is equal to 1 by 2 m VB square plus Hello students, myself Sumit, a physics faculty at Toppers Academy, and today in this video I have come with solution for our NEET test series. So I am going to show you the solution for physics part, and that is for test number CT-01. Okay, which is a complete syllabus test from unit test 1 to unit test 3. Okay. So in this question paper, you can see that problem number 18. Okay, a block of mass 5 kilogram resting on a horizontal surface is connected by a cord passing over a light frictionless pulley to a hanging block of mass 5 kilogram. The coefficient of kinetic friction between the block and the surface is 0.5. Tension in the cord is tension in the cord is. So to solve such kind of problem, we first have to make, so what you can do to solve this problem, you can, so this is the tension acting, this 5 kilogram of block that is moving only because of tension, So on this A block, the forces acting are just this tension. So I can write that this T, this tension minus, and also there is one more force which is frictional force minus Fk. That will be, so T minus Fk is equal to 5A. Acceleration is happening in the forward direction. Now this Fk, that is mu mg. So you can write T minus mu k mg is equal to 5A. What is this equation? For this block, for B block, for block B, one force is acting in the downward direction, which is 5G. A force acting in the upward direction, which is tension. So I can write that 5G minus T is equal to 5A. So this is our second equation. This is our first equation. If I solve these two equations, I will get what the tension is. Only by using these two equations, you can get what the tension is, and that will be equal to 36.75 Newton. Now come to the question number 19. Block A of mass m rests on the plank B of mass 3m, which is free to slide on a frictionless horizontal surface. The coefficient of friction between the block and plank is 0.2. If a horizontal force of magnitude 2 mg, that is 2 mg. That means, mass of block, block of mass m. So this is having mass m. So its weight is mg. Plank B is of mass 3m. So its weight is 3 mg. Now, as this force 2 mg is acting on B, if I assume that A is also moving with B, so what is the force responsible for the motion of A? So on A, there will be a force because that upper surface of B that is going in the forward direction with respect to the lower surface of A. So a frictional force will act on B, a frictional force will act on B in the backward direction. The same frictional force will move A in the forward direction. This is 2 mg. Now what is the maximum value of friction? So the maximum value of this frictional force acting on M, that can be this, the coefficient of friction, which is 0.2 into M, into M into G. That can be the maximum frictional force acting, right? So you can see that, okay, because of this frictional force, this A can have a maximum friction, that is, okay, maximum acceleration. Okay, so maximum acceleration of A block so that they can move together is G by 5. Is G by 5. But if I see this B block, okay, and I apply Newton's second law for the B block. So for B block, I can write that forces acting on B block, okay, forces acting on B block, one is 2 mg in the forward direction, frictional force which is 0.2 mg in the backward direction. So acceleration of B, okay, that will be equal to 2 mg minus 0.2 mg divided by mass of block B, which is 3 m. So that will be equal to 2 minus 0.2 is 1.8 mg, okay, divided by 3 m. Okay, so this will be equal to, okay, 3g by 5. Now, if you see this acceleration of B and maximum acceleration of A with which they can move together, that is g by 5. So what will happen? They cannot move together. Actually, they will slip on each other. Okay, so the acceleration of block A with respect to the ground, A with respect to the ground is g by 5. And acceleration of B with respect to the ground is 3g by 5. Acceleration of A with respect to B, okay, that is equal to g by 5 minus 3g by 5, okay, and that comes out to be minus 2g by 5, okay. So for this question, okay, the correct option is 2g by 5, g by 5, okay. Okay, the correct option is 2g by 5 and g by 5, okay. Now question number 20. Okay, a dynamometer D is attached to two bodies of mass M. Okay, that capital M is having okay, that capital M is equal to 6 kilogram, small m is equal to 4 kilogram. Forces F equal to 20 Newton and 10 Newton are applied to the masses as shown in figure. Okay, so this is dynamometer. Okay. This dynamometer that will read the force, okay, this spring force, the force produced by the spring. Okay, now this F, okay, this capital F, that is 20 Newton. Okay, capital M is 6 kilogram. Now I am assuming that force, spring force, okay, acting, okay, or, okay, if I take this as, okay, as an entity, okay, as a single body. So on this single body, the force is acting, okay, force capital F that is acting 20 Newton in the left direction. So if I use Newton's second law, Newton's second law. So from Newton's second law, I can write that 20 Newton minus 10 Newton, that is equal to, okay, that is equal to small m plus capital M into acceleration of this body. Okay, what is small m? That is 4 kilogram. Capital M is 6 kilogram. So I can write that 10A is equal to 10. Okay, tan A that is equal to 10 Newton, or you can write that actually acceleration is 1 meter per second square. Okay, that acceleration is 1 meter per second square. Now if you see this, okay, if we have only this 6 kilogram of mass, if I consider this mass only, okay, this is the total acceleration of this dynamometer along with these masses. Okay, now if I assume that tension, okay, tension due to the spring, okay, that will act in the backward direction on this. Okay, that will act in the backward direction. Suppose that is T. So from this, you can write that F minus T is equal to 6. So you can write that T is equal to F, okay, minus 6. F is 20 Newton. So 20 minus 6 is 14 Newton. Okay, so this is the answer. Okay, 14 Newton is the answer for this. Okay. Now, question number 21. A stone is rotated in a vertical circle. Okay, a stone is rotated in a vertical circle. Speed at bottommost point is square root of 8gr, where r is the radius of circle. The ratio of tension at the top and the bottom is. Okay. So question is, a stone is rotated in a vertical circle. Speed at bottommost point is square root of 8gr, where r is the radius of circle. The ratio of tension at the top and the bottom is. So the correct answer for this is B. Okay, the correct answer is B. But how we will find that answer? Okay. So that is question number, this was question number 21. Okay. So to solve these kind of problems, okay, suppose that lowermost point is, okay, suppose that lowermost point is A and that top point is, okay, that top point is B. Okay, so to solve this kind of problem, you must apply, okay, so suppose this is our point A and this is our point B. Here tension is TA, that is acting in the upward direction. Okay, and weight of this particle, okay, weight of the particle, okay, weight of this stone, that is acting in the downward direction. Suppose its mass is m, mass is not given, but we are assuming that mass is small m. So weight is acting in the downward direction. Okay, so I can write from here that TA minus mg is equal to mva square divided by capital R. Now VA, that is the velocity, magnitude of velocity at the bottommost point, at point A, that is equal to square root of 8rg. Okay, that is square root of 8rg. So I can write that TA minus mg, okay, is equal to m into, okay, 8rg divided by r. So you will get that tension at A is actually equal to 9 mg. Okay, that is equal to 9 mg. Okay, now as it reaches at point B, okay, as it reaches at point B, so at point B, at point B, we can write that TB plus mg is equal to mvb square divided by r. Okay, at point B, TB plus mg is equal to mvb square divided by r. Okay, now how we can find VB? So we can write from energy conservation. Okay, from energy conservation, I can write kinetic energy plus potential energy at point A. Okay, potential energy, I am assuming it is the, okay, it is the reference point. So potential energy is 0 here. So I can write that 1 by 2 m VA square is equal to 1 by 2 m VB square plus twice mgr. Okay, using that you can find out what is the velocity at point B. Okay, so if we solve it, what we will get, VA square is equal to VB square plus 4rg. Okay, VA square is 8rg, VB square plus 4rg. Okay, So VB that comes out to be, okay, 8 RG minus 4 RG, that is 4 RG. And if you take a square root of that, you will get a square root of 4 RG. Okay. Now you use this value, okay, in this. Okay, if you use this value in this, you will get TB is equal to 3 mg. Okay. So you can find that ratio, okay, ratio of tension, okay, TB by TA, that will be equal to 3 mg divided by 9 mg, that will be equal to 1:3. Okay. So this B is the answer. Okay. Now question number 22. Okay. A block of mass capital M. Okay. A block of mass capital M rests on a rough horizontal surface as shown. Coefficient of friction between the block and the surface is mu. A force F equal to mg acting at an angle theta with the vertical side of the block pulls it. Okay. In which of the following cases the block can be pulled along the surface? In which of the following cases block can be pulled along the surface? Okay. So what we will do, we will make a, okay, we will make a force diagram. Okay, first. Question number 22. There is a block which is capped on the surface. A force is acting, making an angle theta with the vertical. Okay. Mass of this block is capital M. Okay. Coefficient of friction, that is mu. Okay. Coefficient of friction is mu. Okay. Now if I take a horizontal component, that is F sine theta. Vertical component, that is F cos theta. Okay. F cos theta. Normal reaction, okay, acting, that is N. So I can write that N plus F cos theta is equal to mg. From here, you can write that N, actually this normal reaction, okay, normal reaction is equal to mg minus F cos theta. What is the force of friction acting? Okay, limiting friction. Okay. If I write limiting friction, so that will be equal to mu into N. Okay. That will be equal to mu into N. What is mu? That is coefficient of friction. N is mg minus F cos theta. Now to move this block, the force F sine theta must be greater than or equal to the limiting friction. Okay. So you can write F sine theta, okay, plus mu cos theta, that must be greater than or equal to mu mg. Okay. That should be equal to, okay, equal or greater than mu mg. Okay. If this force, okay, now, okay, what they have given, that force is equal to mg. Okay, they have given that force is equal to mg. Okay, if you put this mg, okay, or just 1 minute, okay, this line, we do not require it, okay, I think. You just write, in place of mu, F, you write mg. So from this equation, we can write that mg sine theta is greater than or equal to mu mg minus mu mg cos of theta. Mg and mg, okay, mg is common in all of them, so that is cancelled out. We can write that sine theta is greater than, okay, we can write that sine theta is greater than or equal to mu into 1 minus cos theta. Okay, sine theta is greater than or equal to greater than or equal to mu into 1 minus cos theta, I can write it as 2 sin theta by 2 cos theta by 2, okay, is greater than mu, okay, 1 minus cos theta. You can write it as 1 minus, okay, 1 minus 2 sin square theta by 2. Okay, so you will get 2 sin theta by 2 cos theta by 2 is greater than or equal to mu into 2 sin square theta by 2. Okay, now sin theta by 2 and sin theta by 2, they are cancelled out. Okay, 2 is cancelled out by 2, sin theta 2, okay, 1 sin theta by 2 is also cancelled out. So you will be left with cos theta by 2, okay, cos theta by 2 is greater than or equal to sin mu sin theta by 2. From here you can write that cot theta by 2 is greater than or equal to mu. Cot theta by 2 is greater than or equal to mu. Okay, so option D is correct. Okay, option D is correct. Okay, now come to problem number 25. Okay, a 1.5 kilogram block is initially at rest on a horizontal frictionless surface. When a horizontal force in the positive direction of x-axis is applied to the block, the force is given by 4 minus x square I cap Newton, where x is in meter and the initial position of the block is x equal to 0. The maximum kinetic energy of the block between x equal to 0 and x equal to 2 meter is. Okay, so a 1.5 kilogram block is initially at rest. Initially that block is at rest. Okay, so to solve this question, we can apply work energy theorem. Work energy theorem. And what is that? Okay, that theorem is change in kinetic energy. Okay, change in kinetic energy is equal to work done by all the forces. Okay, so change in kinetic energy is equal to work done by all the forces. Okay, now what is change in kinetic energy? Kinetic energy final minus kinetic energy initial, that is equal to work done by all the forces. Okay, that is equal to work done by all the forces. Now what are the forces? Okay, so F vector is equal to 4 minus x square Newton. Okay, force is equal to 4 minus x square Newton. Okay, now I want to find out what is the work done by this force in moving from x equal to 0 to x equal to 2. So work done is F dx, okay, x equal to 0 to x equal to 2. We can write it as 0 to 2, okay, integrate 4 minus x square dx. Okay, you will find what is the work done. Okay, because it is starting from rest. Okay, because it is starting from rest, initial kinetic energy is 0. Okay, so whatever is the work done, that is, okay, that is converted into the kinetic energy. Okay, and if we calculate it, okay, that comes out to be, okay, the answer for it is 5.33 joule. Okay, so you will get 5.33 joule. 5.33 joule, that is the maximum kinetic energy. Okay, 5.33 joule, that is the maximum kinetic energy. Okay, that is the maximum kinetic energy obtained. Okay, that is the maximum kinetic energy of the block. Okay, now question number, okay, now let me discuss with you. Okay, now let me discuss with you question number 27. Okay. So to solve this question, you just have to apply energy conservation law. Okay. You have to just apply the energy conservation law. Okay. So if you apply that energy conservation law, you will get your answer. Okay. Question number 28. In a conservative field at stable equilibrium, potential energy is. So potential energy is minimum. Okay. Potential energy is minimum. Question number 29. Okay. A ball of mass m moving at a speed v makes a head-on collision with an identical ball at rest. The kinetic energy of the balls after the collision is 3/4 of the original. Find the coefficient of friction. Okay, so for that you can use these two formula. Okay. So let me write these formula. Okay, just one second. This formula for question number 29. Okay. Okay. A ball of mass m moving at a speed v makes a head-on collision with an identical ball at rest. The kinetic energy of the balls after the collision is 3/4 of the original. Find the coefficient of restitution. So for that, first I will write, okay, first I will write two expressions. Okay, now suppose there are two balls which are moving with velocities. Okay, one ball is there and another ball is there. Okay, suppose one is moving with the velocity v1, another is moving with a velocity v2. Okay, suppose mass here is m1, mass here is m2. Okay, they both are having masses m1 and m2. Okay, so what will be their velocities after the collision if that collision is not perfectly elastic, if it is a inelastic collision? Okay, so you can write that after the collision their velocities will become, okay, just one second, okay, their velocities will become v1 prime equal to, okay, that v1 prime is equal to m1 minus em2 divided by m1 plus m2 v2 plus m2 plus e2 m2 plus em2 divided by m1 plus m2, okay, divided by m1 plus m2 into v2. Okay, here it is v1. Okay, so here it is v1, and velocity of the second one, okay, that will be equal to, okay, that will be equal to m1, okay, that will be equal to m2 minus em1. Okay, that will be m2 minus em1 divided by m1 plus m2 into v2 plus m1 plus em1 divided by m1 plus m2 into v1. Okay, so these are the velocities after the collision. Okay, so you can use these two expressions. Okay, and also because kinetic energy, the kinetic energy of the balls after the collision is 3/4 of the original. Okay, so one you can use that 1 by 2 m v1 square plus 1 by 2 m v2 square, okay, is equal to, okay, actually kinetic energy after the collision, that is 1 by 2 m v1 prime square plus 1 by 2 m v2 prime square, that is 3/4. Okay, that is 3/4 of the initial kinetic energy. Okay, you solve these two. Okay, and if you solve these two, you will find out the value of E, and that value of E, okay, you can from there you can find out what is the value of E. Okay, value of coefficient of restitution. Okay, so this is for question number 29. Now come to question number 30. two particles of masses 0.5 kilogram and 0.25 kilogram moving with velocity 4 meter per second and minus 3 meter per second collide head-on in a perfectly inelastic collision. Find the velocity of the composite particle after collision and kinetic energy lost in the collision. Okay. So what you can do, you can write that initial momentum. Okay. So what is initial momentum? Because they are moving in the opposite direction. Okay. So 0.5 into 4.0 minus 0.25 into 3.0. Okay. That will be equal to 0.5 plus 0.25 into, okay, into V. And from there, you can find out what is the velocity. Okay. Okay. From there, you can find out what is the velocity. Okay. And also, and that velocity comes out to be 1.67 meter per second. That comes out to be 1.67 meter per second. What is the kinetic energy lost? Okay. So the initial kinetic energy is equal to 1.2, 0.5 into 4 square plus 1 by 2 into 0.25 into 3 square. Okay, that will be the initial kinetic energy. What is the final kinetic energy? That final kinetic energy will be equal to 1 by 2 of 0, okay, 1 by 2 into 0.5 plus 0.25 into 1.67 square. So you will get some value of the, okay, final kinetic energy. That is not 0. Okay, that is not 0. Okay, you will get some value. Okay, you will get some value. Okay, and from that value you can calculate what is the loss in kinetic energy. Okay, so you will get your answer. Okay, A. Okay, so A is the correct answer. That will be the loss in kinetic energy, and 1.67 meter per second, that is the velocity. Okay, now a grinding wheel attained a velocity of 20 radian per second in 5 seconds starting from rest. Find the number of revolutions made by the wheel. So a grinding wheel attained a velocity of 20 radian per second in 5 seconds from rest. So its initial, okay, its initial angular velocity was 0. Okay, its initial angular velocity was 0. Okay, so this is question number 4, question number 31. Okay, I'm going to solve for question number 31. So initial angular velocity is 0. Final angular velocity, okay, final angular velocity is 20 radian per second, and that much angular velocity has been attained in 5 seconds. So you can write what is alpha, what is angular acceleration. That is equal to 20 minus 0 divided by 5. That is equal to 4 radian per second square. Okay, that is 4 radian per second square. Okay, now how many number of revolutions? Okay, so for number of revolutions, I can find out what is the angular displacement. That is equal to, okay, or you write it as omega naught. Okay, so omega naught t plus 1 by 2 alpha t square. This term goes to 0 because omega naught is 0. 1 by 2 alpha is 4 radian. So 4 into t square. Our t is 5 seconds. So multiply it by 25. You will get 50 radian. That is the angular displacement. And from this 50 radian, you can calculate how many number of revolutions are there. So 50 divided by, okay, 50 divided by 2 pi. Because in one revolution, okay, angular displacement is 2 pi radian. Okay, so you will get that number of revolutions are equal to 25 by pi. Okay, number of revolutions are 25 by pi. Okay, now next question. Okay, the magnitude, okay, the magnitude of displacement of a particle moving in a circle of radius with a constant angular speed, okay, with a constant angular speed varies with time. Okay, how it varies with time? Okay, so question number 32. Okay, so the magnitude of displacement of a particle moving in a circle. Okay, so that particle is moving with in a circle with a constant angular speed, right? Suppose that constant angular speed is omega. Then at after, okay, at a time t, okay, if I want to measure its y coordinate, okay, so x coordinate, that is a cos theta, y coordinate, that is a sin theta. Okay, if you see that, okay, so angular displacement, you can get that angular displacement is a, okay, a, okay, if it is a, that is a sin theta, okay, and this is, okay, if it is starting from here, okay, it was here initially, okay, suppose this is point A and reaches at this point B, okay, so initially, okay, it was having coordinates A 0. Now it is having coordinates, okay, y coordinate is a sin theta. What about x coordinate? Okay, that x coordinate is a cos theta. Okay, now if you want to find out the displacement, okay, magnitude of displacement, you take the direct distance between them. Okay, so this AB, that will be equal to square root of a cos theta minus a whole square plus a square sin square theta. Open this bracket. What you will get if you open this bracket? You will get a square cos square theta plus a square minus twice a cos theta plus a square sin square theta. Okay. Now, a square cos square theta plus a square sin square theta, that is a square. A square plus a square is 2a square. Now I can write that AB. Okay. I can write that AB is equal to square root of, okay, AB is equal to, AB is, okay, square root of, okay, a square sin square theta plus a square cos square theta, okay, that is a square, okay, so under root of twice a square, okay, so under root of twice a square, okay, just one second, under root of twice a square minus twice a cos theta, that will be the magnitude of the displacement. Okay, under root of twice a square minus, okay, twice a square cos theta. Okay, just one second. Minus twice a square cos theta. Okay, if you see this, okay, you will get a square cos square theta plus, okay, minus twice a square cos theta. Now this theta is varying according to omega t. Okay, that is equal to omega t. That angle, because omega is the angular speed, so angle is changing. If initially that angle is 0, then this theta is equal to omega t. You write it as omega t. Now you can write that this AB is equal to, okay, that magnitude of displacement is equal to, okay, 2a square is common in both of them. So root 2a into square root of, okay, 1 minus cos omega t. What is cos omega t? Okay, that cos omega t you can write as equal to, okay, so 1 minus cos omega t. So 1 minus cos omega t, that is equal to 2 sine square omega t by 2. If you will open this bracket, you will get AB is equal to 2A sine omega t by 2. Okay. So that is the magnitude of displacement. Okay. So that is the magnitude of displacement. Okay. Now let me see. Okay. Let me see solution for another question. Okay. Question number 34. If three vectors along coordinate axis represent the adjacent sides of a cube of length b, then the unit vector along its diagonal passing through the origin will be. Okay. If three vectors along coordinate axis represent the adjacent sides of a cube of length b, then the unit vector along its diagonal passing through the origin will be. Okay, so that is a very easy question. Okay, so that is very easy. Okay. Okay, now if I take this point, okay, that will be the diagonal. Okay, if you join these 2 points, okay, that will make the diagonal. Okay, passing through the origin. So I think okay, so the correct answer is this one. Okay, out of these 4, this is the diagonal. Okay, that will represent the diagonal. Okay. Now come to question number 36. Okay, question number 36. Dimensional formula for coefficient of viscosity. Okay, F equal to 6. If we use this formula 6 pi eta RV, then what that will be? Okay, so that is a very simple question. Okay, dimensional formula for coefficient of viscosity using this formula. So we know that F is equal to 6 pi eta RV. 6 pi eta RV. Now this eta, that is equal to F divided by 6 pi RV. Okay, 6 pi RV. So we can write dimensional formula. Okay, just 1 second. Question number 36. Okay, for question number 36, we can write that F is equal to 6 pi eta RV. Now we can write the dimensional formula for eta is equal to dimensional formula for F divided by dimensional formula for 6 pi RV. Okay, so dimensional formula for F is MLT minus 2. Dimensional formula for 6 pi, okay, it is a constant. Okay, dimensional formula for R, that is L. Dimensional formula for V, that is LT minus 1. Okay, so you will get ML minus 1, ML minus 1, T minus 2. That is the dimensional formula for eta. ML minus 1. Okay. Okay, so dimensional formula for eta is, okay, you can see from here, that is, okay, MLT minus 2 divided by, okay, L2 T minus 1. So ML minus 1, T minus 1. Okay, T minus 1. So ML minus 1, T minus 1, D is the answer. Okay. So the right answer for it is D. Now the question number 37. Okay. The dimensions of wavelength lambda is, okay, so the dimensions, okay, for wavelength, that is simple, M0, L, T0. Okay. So this is all for today. The remaining part of it we will see in the next video. Okay. Thank you.